Welcome back, guys. Today I will be exploring the principles of a circle. And it's important to understand the principles of a circle. If we understand the principles of a circle, we would we should be in a better position to be able to apply it to solve technical problems. In a geometric construction, the use of arcs and circles is very, very prevalent. Let us explore a circle. A circle typically has a radius, and a radius is the distance from the center to any straight point on the circumference. So from here to here is the radius, right? The total distance around the circle is referred to as the circumference, all right? As a circumference. Based on what we have here, if from here to here is a radius, the diameter is the distance from one point on the circumference that runs straight through the center across to the adjacent point on the circumference. That's the diameter. It means therefore that 2 radius equals to 1 diameter, or 2 radii, which we really don't use, equals 1 diameter. We also have a part of the circumference which is referred to as an arc. As an arc. Alright? In drawing, while doing construction, we typically use arc. Like when blending of arcs, blending of lines and circles, we typically use arc. But an arc is basically half of a circle. Something very, very important which I want us to pay special attention to is that, which is to be is obvious, but it needs to be reinforced, that from the center of a circle, from the center, every point from the center out to the circumference measures the same distance. So knowing that, we can use that principle to construct different type of figures. Say for example, a triangle when given the length of all 3 sides, right? In this case, say we have a triangle AB, which is 50, BC, which is someplace up here, is 70, and AC is 50, let's use 40, right? We can find point C by using the principle of circle. Yes, knowing that from here to the circumference, or from this center to the end of this point, is 40, and also from this point, which is B, out to the end of this point, to the end of the circumference, is 70 millimeters. We can use that principle to find point C. All right? A practical example. Say for example we have a line here, and this line is this. All right? This is our line. All right? This is the center of this line. That's the center. Right. Now, if we're to use this, for example, using here as point A, using here as point E, 1 point. If we're to draw an arc with this radius, and if we were to use, say, another circle, let's use this circle. at the point where both of them meet would be point C. Note here that where both arcs meet, that is point C. So that's where point C is formed. And remember, if from here to here is 60 or 40 or 70, whatever the case may be, is a point where both of them meet. That would be the point. Alright? I realize that some students have challenge where that is concerned, where they are not quite sure. I mean, they pretty much use a ruler to get one point, and then the other point doesn't really blend in to the equivalent distance from the other side. So once you understand this principle, you'll be able to get it, because once you use the center, anywhere on this circumference is a particular distance apart. So it doesn't really matter the size of the circle per se, as long as you use the point where both of them meet. Hopefully I'm making some sense.